Welcome to Running Biomechanics. All movement generates torque to varying degrees. Torque occurs throughout the entire running gait cycle or stride. It occurs through the upper limbs, lower limbs, and torso. Definitions of torque and angular movement are shown here. As a runner's left foot strikes the ground, he pushes off with a force. This force causes a torque to be exerted on his body, which tends to rotate his torso in the direction shown in the diagram. The runner simultaneously swings his arms in the opposite direction, which exerts a counter torque on his body. This rotates the torso in the opposite direction. The generation of this counter torque helps keep his body stable and facing forward as he runs. There are several factors affecting torque, such as the length of the lever arm and the force produced. Other factors that affect torque are muscle activation, strength, range of motion. Angular force is occurring throughout the entire gait cycle or running stride. As the runner runs on the treadmill, he is producing several different forces: a horizontal force, a vertical force, and a gravitational force. Several ways to improve running technique. Proper foot strike through the dorsiflexion will allow for more lower body musculature to be engaged during the running cycle. Be aware of your joint positions and how you are supporting your joints. Muscles need to do the work of supporting the joint under the strain of torque. Studies have shown that increasing hamstring activation during the swing phase can assist in reducing torque at the hip. A study looking at barefoot versus running shoes is shown here. An average of 54% increase in the hip internal rotation torque, a 36% increase in knee flexion torque, and a 38% increase in knee varus torque were measured when running in running shoes compared with barefoot. If two equal but opposite forces are applied to a stationary body, then no work is done. Work is being done by the body as a whole, traveling a distance because of a force being applied over a distance, and work is also being done within the muscle to create this force. Work is done by the average force multiplied by the distance over which the center of mass moved. In this case, the distance the runner traveled during each gait cycle. The total work of the runner can be calculated if we combine the total force and the total distance traveled of the entire run. Work is constantly being done throughout the running gait cycle because the person is constantly moving forward, relevant to the treadmill, giving a positive work amount. Power, however, is being produced only during the stance phase, or ground contact, of the running gait cycle. Power is increased when a given amount of work is done in less time, and increasing power results in an increase in velocity of a person, which ultimately means the more power produced during ground contact time in the forward direction, the faster the runner will run forward. The amount of work being done and the power being produced with each step converts into kinetic energy. Kinetic energy is the energy associated with motion. Kinetic energy is being produced throughout all of the running gait cycle, the stance phase and the swing phase, for the fact that some parts of the legs are always moving. Though the amount of kinetic energy is not constant, some of the total energy is also potential energy. Potential energy is increasing while the leg lifts during the swing phase to the highest point of the knee lift, and then begins to convert back down to kinetic energy during the downward motion and the stance phase. Also, faster moving objects have far greater kinetic energy, which infers that more power is being produced. As we remember, more power will increase the runner's speed, which in turn will increase the runner's kinetic energy. Several factors involved are shown here. In the chart, we can see the average muscle activation levels during one gait cycle. Activation can be connected to work done and power output. The red muscles are producing more power, thus using more energy, which leads to more work being done, while the blue muscles are producing less power. The key for a runner is to use more power in an efficient manner, using the power generated in the propulsion phase, propelling forward, rather in a braking impulse act of running, which will use less energy to propel the runner forward. By reducing the braking impulse, the force needed to overcome this negative momentum will be less. Some recommendations to improve running performance are shown here. Let's consider what occurs when the runner's foot collides with the ground. In a collision, the total momentum of the system is equal to the sum of the mass times velocity of all the colliding objects. In heel striking, the collision of the heel with the ground generates a significant impact transient, a nearly instantaneous large force that sends a shock through the body, about 1.5 to as much as 3 times your body weight within 50 milliseconds of striking the ground. In forefoot striking, however, the collision of the forefoot with the ground generates a very minimal impact force with no impact transient. Note that there is a continuum of different kinds of landings, from landing on the heel to landing simultaneously on the heel and ball of the foot, called midfoot striking, and landing on the ball of the foot, forefoot striking. This is further shown in the following graphs. So one can avoid experiencing large impact forces by forefoot striking properly to keep your feet happy.